all to another session of Concept at Fingertips. This is Vidya, Physics faculty. Today, let us learn about the topic electric motor. So basically, what is an electric motor? An electric motor is a rotating device. It's a rotating device that converts electrical energy into mechanical energy. So it converts electrical energy to mechanical energy. So this electric motor can be seen in many of the appliances like electric fans, mixers, washing machines, etc. So what is the basic principle of working of electric motor? Let us see the principle of working principle. When a current carrying conductor is placed within the field of a magnet, within a magnetic field, it experiences a force. It experiences a force and moves. So this is the working principle of electric motor. So let us see the construction and the working of the motor. Motor construction. So it basically consists of a rectangular coil as shown in the figure named ABCD. So this is a coil of insulated conductor and the coil is placed between the magnetic fields of this magnet as shown in the figure, two sides of a magnet, north and south poles of a magnet. And the coil is placed in such a way that the coil is perpendicular to the direction of the field. So in this figure, if you see, the direction of the field is from north to south. So the conductors AB and CD, the two conductor sides AB and CD of this coil are perpendicular to the direction of the field. So the field direction is from north to south as shown in the figure. And we can see that the conductors AB and CD are perpendicular to the field direction. Now the ends of the coil are connected to the two ends of the coil are connected to split rings. They are connected to two split rings namely P and Q. So these are connected to the split ring and the inside part of the split ring is insulated and it is connected to an axle. So the external conducting edge, so the left side edge, right? This is the external conducting edge of the split ring and that is connected to two brushes. And in this figure, it is named as X and Y brushes, X and Y. So these brushes are again connected to an external circuit with a battery and a key. So once we supply this current, through the external circuit, the current flows through A to B to C and to D and then comes back. So the current in the coil ABCD basically enters from the source battery through the conducting brush X and flows through the coil and back to the battery through the conducting brush Y. So in the arm AB, the current flows in the direction A to B. So in arm AB, let's consider arm AB for now. So in arm AB, the current flows from A to B. So it is as indicated with the green arrow. And we already know that the field direction, we already know the direction of the field is like that, from north to south as indicated. So this is the direction of the field, this is the direction of the current, this is the current, and this is the field direction. Now by using Fleming's left-hand rule, we can find out the direction in which the conductor AB will experience force. So Fleming's left-hand rule, according to that rule, if the forefinger is oriented in the direction of field, magnetic field, and middle finger in the direction of current, then the thumb points to the direction of force experienced by the conductor. So Fleming's left-hand rule, what does it say? Says that if you stretch the three fingers of the left hand, namely thumb, forefinger, and middle finger, in such a way that they are mutually perpendicular directions, and if the forefinger represents the field and middle finger represents the current, then the thumb points the direction of the force experienced by the conductor. So when we orient our left hand by Fleming's left hand rule, we can see that the conductor AB actually moves downward. So the conductor AB will experience a force downward as shown by the arrow. And in the same way, we can find out the direction of force experienced by the conductor CD. For that, what we have to do is basically we have to find out the current. So the current in CD, the conductor CD. So in arm CD, the current flows from C to D. C to D. Again, if you apply the Fleming's left-hand rule, we will find out that the direction of the conductor, direction of force experienced by the conductor will experience an upward force. So AB will experience a downward force and CD will experience an upward force. There's the coil and the axle. So the coil and the axle, which is free to rotate. So all these things will rotate. So this is how the working of electric motor is. So here the split ring is also known as a commutator. Split ring is also known as a commutator because the split ring reverses the current direction every half rotation. So here the split ring used here, PQ, is also known as a commutator. Split ring is called the commutator. Because it reverses the direction, it reverses the direction of the current. Of the current every half rotation. So this is the basic working of an electric motor. The commercial motors use actually electromagnets in the place of the permanent magnets shown in the figure. They use the electromagnets. And also there will be more number of turns in the coil. Instead of A, B, C, D, just one coil, there will be more number of turns. And there may be a soft iron core on which the coil will be wound on. So all this will enhance the power of the electric motor.